A linear equation is one that has the variable by itself or with a coefficient. Which of these 5 equations are linear? Well, we have this has a variable by itself, with a coefficient, but nothing else. And those are just numbers. So that means that one is linear. This one has a variable by itself with a coefficient, with a coefficient, with a coefficient, and the rest numbers are just by themselves. So that one's linear. This third one here has x squared, and x squared equals x times x, which means the variable is not by itself. It's actually with another variable, which is itself. It just happens to be. And that means this is not linear because x has a multiplication by another variable. Now this one is interesting because we have 2 different variables, but they are by themselves. Well, they're with a coefficient, but they're by themselves variable-wise. It's just x here, and it's just a y here. So that makes this equation linear. This final one has x and y, which means it is not linear. Now, this equation here, this is linear in 2 variables. This actually makes a function. But because the variables are separated, they're not multiplying each other, that means it is in fact linear. And we can have equations like this with as many variables as we want, as long as they're by themselves. For instance, 3a plus b plus 2c minus 3d plus 16f. Let's do e minus 1.2333 e equals 4. All of these variables are not multiplying, I should say this one's f, are not multiplying another variable. Therefore, this whole equation is linear, just linear in 6 variables. So it could be linear in 6 dimensions, that kind of idea. Now, because these are equations, we can actually solve for the variable, not when it's this one or this one. We cannot solve for a single variable and get a single solution. We have to solve a different way. But for these types of equations, these we can solve. And we do that by just getting the variable by itself. So let's say we have these 3 equations here. Let's solve by getting the variable by itself. On this top one, I'm going to distribute the 4. And we get 2x minus negative 4 times 5 is negative 20. Negative 20x. Negative 4 plus 1 is negative 4. And that equals 3x plus 38. Now I'm going to get the x's to one side and the numbers to the other side. So let's add 20 to the right-hand side. That, of course, cancels the 20 here. Gives us 2x. Oh, I forgot this 2x actually. I can take care of that next. 20 plus 3 is 23x plus 38. Let's move this 2x to the other side as well. So the 2x's cancel. We should actually combine those like terms first, but this is fine as well. If you forget to do that, you can still keep going. Now I'm going to subtract the 38 to the other side, giving me 21x equals negative 4 minus 38 is going to be negative 42. So to get x by itself, I'm going to divide by 21. That cancels the 21 and gives me x equal to, I should have done this in red, not black. Negative 42 divided by negative 21 is negative 2. And that gives me a solution for what x is equal to. All right, now let's do the next one. I'm going to distribute the 11 because it's in front of parentheses. And we never want parentheses when we're trying to solve for something. So getting rid of them is going to help you. There are cases when you do want parentheses, but most of the time, get rid of them. It's going to be better. 11 times x is just 11x, and 11 times 3 is 33. Now this is what I should have done in the first case. I have like terms here, so I'm going to combine them, and that's just 11 plus 3. When they're on the same side of the equation, we combine like terms by doing the operation. In other words, 11 plus 3. When they're on opposite sides of the equation, like here, you can see that we do the opposite signs. So this was a minus, plus, we do the same thing on both sides of the equation. This one here was a plus, so we did a minus, and we do both things on same thing on both sides of the equation. It's the same thing is true for when we're doing getting the numbers over. The same thing on both sides of the equation, right? Here's the equal sign. We gotta make sure we do the same thing. So here, these are on the same side of the equation sign, right? They're both on this side. So all we have to do is 11 plus 3, because 11 is positive and 3 is positive. Well, we just combine those by saying 11 plus 3 is 14x plus 33. We don't do the opposite, like we wouldn't do 11 minus 3x, because they're not on opposite sides of the equation. Make sure you remember doing that when you first learn how to solve for a variable. Okay, to get this thing solved, we need to get the variable to one side. So I'm going to subtract 14 from this side and do it to the other side. And you see we have a unique case here. The x's all cancel. And we get 10 equals 33. But 10 does not equal 33. That's not a true statement. And so we say we have no solution. That's because we ended with a false statement. Therefore, there's no x value we can plug into there to make it a true statement. It's always going to be false. Last one, I'm going to distribute the 7. 7 times x is 7x. 7 times 21. I actually wrote the wrong thing here when I was making this. This is supposed to be a 3. And you'll see why. This is going to be 7 times 3, and that gives us 21. And now we can subtract and get the same, x's to one side, but again, they all cancel. And now we have negative 21 equals negative 21. And that is a true statement, which means this thing has infinite solutions. That's how this works. If we can solve for x like we did in this top one, I'll do green here. If we solve for x, we get a single variable, or I should say a single number for x that makes this thing true. That means that this equation is true based on the condition that x equals negative 2. This is called a conditional solution. It's conditional based on x equaling 2. Now, the next one has no solution. That's because we had a false statement. There is no x's that make this thing true. This is called an inconsistent solution, or an inconsistent equation. The last one, when we distribute it all out, you see here at this step here, 7x minus 21 equals 7x minus 21. That's actually the same thing. They are identical. And whenever you have identical things on both sides, you get infinite solutions. And this is called an identity. Now, typically, whenever we do this, we're really looking for this type of problem here. We really want to have a solution, a conditional solution. The other two happen, so it's important to know what they are, but they're kind of like special cases that you don't really want unless you're looking at certain very special systems. But what we're really looking for is a conditional solution. All right, let's add some fractions to these and do the kind of problems with fractions. Okay. We need to get x by itself, but now we have to deal with fractions. However, there's a handy trick to doing these types of problems that make it a lot simpler and actually make it more like the previous problems we were doing. What we're going to do is we're going to look for what is the lowest common denominator for both of these things. So for the first problem, we have denominators of 2, 2, 5, and 10. What is the smallest thing that 2, 5, and 10 can all go into? Or in other words, divide evenly. They can all go into 10 evenly. 2 times 5 is 10, 5 times 2 is 10, and 10 times 1 is 10. Now you can of course use 20 or 30, 50, a million. You can use all of those things. Those are all common denominators. They're not the least common denominator. You want to use the least because it makes the numbers the smallest and it's going to be the easiest to work with. So that's your goal, is to always find the least common denominator, which would be 10 for this. So I'm going to multiply everything by 10. This distributes on this side, and 10 times 1/10, that just becomes 1. So on the left-hand side, 10 times x over 2, you can write this a number of ways. I'm going to write like this. Well, I'll actually distribute it first, I think. That might be the simplest to understand. I'm going to write it as 10 over 1, and then multiply everything by 10 over 1. This is over 1 as well. And now we can cross cancel. I'm dividing each by 2. And then here I'm going to divide each by 5. And then here I'm going to divide each by 10. Now we have 5 over 1 times x over 1. That becomes 5x over 1, which is just 5x. Then we have 5 over 1 times 1 over 1. That's just going to be 5 times 1, 5. And 2 over 1 times x over 1 is 2x. This equals 1 over 1 times 1 over 1, which is 1. And now you see that when you multiply everything by the least common denominator, or a common denominator in general, all of the fractions will cancel, and we can proceed like we did in the previous problems. Let's combine the like terms. We have 5x and negative 2x on the same side. So all we're really going to do is do 5 minus 2 is 3x. And the negative 5 just comes down. I'm going to add 5 to both sides, giving me 3x equals 6. And then divide by 3 to get x equal to 6 over 3 is 2. X equal 2, this gives us a conditional system. It's based on the condition that x equals 2. That's what makes this equation true. You can, of course, test this by taking 2 and plugging them into x and seeing what you get. You should get 1/10. Okay, let's do the same type of problem, or same method on the second problem. What's the least common denominator between 3, 4, and 2? Or in other words, what can 3, 4, and 2 all go into? They can all go into 12. I'm going to multiply everything by 12. Now, I can do it like I did in this problem here. I can write 12 over 1, multiply it through. But most of the time, you want to do this a little bit faster. Really what we're going to do is we're going to say 3 divided by 12 is 4. So the first thing that's going to be multiplied to this 3x plus 1 is going to be 4 times 3x plus 1. That's because this 3 canceled with a factor of 3 and 12. And 12 divided by 3 equals 4. 12 divided by 4 is 3. So the next thing is going to be 3 times 1 minus x. And this negative just comes with it. On the other side of the equation, this can be reduced down to 6. So we have 13 times 6. 13 times 6 is 78. And once again, we have no more fractions, and we can continue the problem like we normally would. Now, if this simplify, or this shouldn't say simplified, if this faster method that I did here is confusing, just go back and multiply everything by 12. One minus x over 4. 12 over 1 here. And then you can see that 3, this becomes 4, this becomes 3, this becomes 6. And we get the same thing again. I recommend understanding how to do it so you can do the faster method first, or in general. It's going to save you time when you're doing these types of problems. Now we can distribute the numbers in front of the parentheses. 4 times 3 is 12x. 4 times 1 is 4. Negative 3 times 1 is negative 3. Negative 3 times x is positive 3x equals 78. Combine like terms. They're on the same side of the equation again, so all we have to do is do 12x plus 3x is 15x. These are also on the same side of the equation, and they are like terms, so plus 4 minus 3 is plus 1. Subtract 1, 77, and divide by 15. This cannot reduce at all. If it could, we would always reduce. So this is our final answer, and this is again a conditional system. The original problem, this original problem here, this is only true when x equals 77 over 15. You can, of course, check this, plug this into the x's, and you'll see that x right there. You'll see that you get 13 over 2 on the left-hand side. Now, if we were to put variables in the denominator, see here for both of these problems, we only had numbers in the denominators, 2, 2, 5, 10, 3, 4, and 2. If we had a variable in the denominator, we no longer have what's called a linear equation. Now we have what's called a rational equation. It becomes a completely different type of thing. However, as long as it's linear, namely all the x's are by themselves, they're not multiplying by another variable. As long as it's linear, we can typically make it into a linear equation. And we're going to use the same idea as we did with these two problems, using the least common denominator. Let's do that. The first step is to always factor the denominators. And for this left problem here, the first denominator, x minus 3, that's already factored. So it's a linear term, so there's nothing we can do there. However, 2x minus 6, that is not factored. That we can take out a 2 from both things. So 2x divided by 2 is x, and 6 divided by 2 is 3. And now the least common denominator here, we can see, is going to be 2 times x minus 3. That's because x minus 3 can divide evenly into this. 2 times x minus 3 divided by x minus 3 is going to be just 2. And then 2 times x minus 3, that of course can divide evenly into that because it's the same thing. You'll get just 1. Before we do that, we need to ask what makes the denominator equal to 0. Whenever we have a variable in the denominator, we have to exclude 0 numbers that make it 0. If x equals 3, you can see that 3 minus 3 is 0, and we get a 0 in the denominator. And 3 minus 3 is also 0 on the right-hand side. making it 0 in the denominator. So we have to exclude x equal to 3. That's going to come into play at the very end of solving this thing. Now we can continue by multiplying both sides by 2 times x minus 3. And we can cancel like terms. Those cancel, and the 2's cancel, giving us just 1 on the right-hand side. 2 times 1 is 2, and 1 is just on the right-hand side. And you see we get a false statement. 2 does not equal 1. So we say no solution. This is an inconsistent system. It has no solution. Okay, same idea for this next one here. We're going to factor the denominators first. This one's already factored. 1 is always over 1. Any number by that's just written there without a fraction. Put it over 1. It's going to help you out. This one right here, we can use the AC method for this. A times C is -3, and B is +2. Because A here is going to be 1, right? There's a 1 right in front of the x squared. We can use the shortcut method for the AC method, meaning once we find these two numbers, we can immediately factor it. What two numbers multiply to give -3 and add to give +2? Multiply to give 3 is easy. It's going to be 3 and 1. That's the only combination possible. Now to add to give +2, one of these has to be negative. That's going to have to be the 1. 3 times -1 gives us -3, and 3 minus 1 gives us +2. We can immediately factor this into x plus 3. That's a +3 there. And x minus 1. That's the shortcut method that I've shown before in other videos. Okay, what's our least common denominator? Well, we have x plus 3 here. This one's 1, which means it can pretty much be multiplied by anything. And this one here is x plus 3 times x minus 1. That means our least common denominator, since x plus 3 and x plus 3 in both of them, is going to be x plus 3. And what does this thing here need that this thing has? It has an x minus 1. So we have x minus 1 as well. Now we can always check to make sure that it divides, that's in fact a common denominator. We do the least common denominator and divide it by each one of these denominators here. As long as we get a whole number in the result, then it's a common denominator of some kind. It could be the least, it could be just common denominator. If we're left with a fraction at all, we know that it's not the least common denominator because it doesn't get rid of the fraction. We need to get rid of the fraction. So x plus 3, the first one here, you see that it cancels with that one and the denominator goes away. We're left with just x minus 1. So that's good for that one. If we have, next is going to be this 1. Well, anything divided by 1 is the thing by itself, so the denominator cancels and we're good to go. So it's good for the second one. Last one. This one should be the most obvious because everything cancels here. When everything cancels, that means you just have a 1. This equals just 1. And the fraction does indeed go away. So we're good there as well. That means we can continue. Whoops, I didn't mean to erase. X plus 3, x minus 1. We can continue by multiplying everything by the least common denominator. I'm just going to rewrite the problem here so it's a little bit simpler to see. I will write 1 as 1 over 1 though. Minus x plus 3 minus 1. Okay, now x plus 3, x minus 1. This gets distributed into all the terms. On the left-hand side, those canceling, giving us x minus 1 times x plus 2. X plus 3 times x minus 1 times this thing times the 1 over 1. That's just going to be the thing by itself. So x plus 3, x minus 1. Because this is really just multiplying 1, so that's all we need. And then you see that x plus 3 and x minus 1 cancel, giving us just 1. Now we have an equation that has no denominators, so we can continue to see if this becomes a linear equation. Now this doesn't look like it does, because we have a thing of x times a thing of x, so that should give us x squared. But let's continue. Both of these we can FOIL out. X times x is x squared, x times 2 is plus 2x, negative 1 times x is negative 1x, and negative 1 times 2 is negative 2. Again, I'm just foiling. X times x is x squared, x times negative 1 is negative 1x, 3 times x is positive 3x, and 3 times negative 1 is negative 3. And that negative 1 just gets brought down. Now we see that this isn't technically a linear equation because we have x squared. However, I can subtract x squared from both sides and they cancel. And what remains is in fact linear. So we can continue the same process. I did forget a step though. Shoot, I can't believe I forgot that. I just remembered it. We need to see what x's do we have to exclude. X cannot equal, when does it make it 0 in the denominator? For here, negative 3 plus 3 is 0. We have to exclude a negative 3. This is also a negative 3 plus 3 is 0. This right here is a 1 minus 1 is 0. So positive 1 must also be excluded here. So those are the two numbers we have to exclude, and that'll come into play at the very end. It didn't really do anything on this problem because we had a false statement, so there was no solution in general. But in this problem, hopefully it'll come into play. Okay, I'm going to combine like terms here. Positive 2x minus 1 is just x minus 2. Negative 1 plus 3 becomes plus 2x. No point in writing the plus 2. Negative 3 minus 1 is negative 4. Now I can subtract x to the other side, giving us negative 2 equals x minus 4. And I can add 4 to both sides, giving me 2 equals x, which is a conditional answer to this system. Now, because we have a solution here, we have to go back up and make sure the solution is not one of these. X cannot equal negative 3 and 1. This, of course, is x equal to 2, which means we're good to go. If, for instance, we got x equal to negative 3 after all of this work, we got this point here, and we knew that x could not equal negative 3, we must exclude that answer. And since we only would have one answer, we would say no solution. That, of course, isn't the case here. X equal to 2 is a solution. It's not excluded, and that gives us a conditional answer to this system.